As we know, there are 118 known chemical elements. Each element is unique and exhibits distinct chemical and physical properties. Every element is made up of subatomic particles, namely protons, neutrons, and electrons. Although all elements contain these particles, the numbers of these particles vary from one element to another. Each element possesses a unique number of protons in its nucleus, which is called its atomic number. Therefore, the atomic number of an element is the number of protons present in the nucleus of an atom of that element. It is represented by Z. This unique proton count distinguishes one element from another. For example, hydrogen carries one proton, so its atomic number is 1. Helium carries 2 protons, so the atomic number is 2, and iron carries 26 protons, which gives it an atomic number of 26. The numbers of electrons and neutrons may also vary and influence the chemical behavior, but they do not change the identity of the element. For example, hydrogen exists in nature in 3 different forms, such as protium, which contains 1 proton and no neutrons, deuterium, which contains 1 proton and 1 neutron, and tritium, which carries 1 proton and 2 neutrons. Although these 3 differ in the number of neutrons they contain, they all possess the same number of protons. Therefore, all of them are classified as hydrogen, and all have an atomic number of 1. Like atomic number, which represents only number of protons. Mass number represents total number of protons and neutrons present in the nucleus of an atom. One question you may now ask, if atoms have identities, and it is fixed by the atomic number, what is the need for the mass number? It is necessary because all atoms of the same element do not always have the same mass. For example, atomic number of carbon is 6. It has 6 protons, which gives it unique chemical identity. But in nature we found 3 different forms of carbon atoms, such as carbon 12, carbon 13, and carbon 14. Though all have same number of protons, their mass is different because their nucleus carries different number of neutrons. So mass number says about total number of protons and neutrons present in an atom. Here, it is important to note that mass number is not same as the mass of atom. It represents the nuclear constitution. It is represented by the symbol A. Now, we know the atomic number, which is represented by Z, and the mass number, which is represented by A. Z stores the identity of the element, whereas A represents the different forms or isotopes of an element that exist in nature. With this, a particular element is represented by this, where X is the symbol of the element, Z is its atomic number, and A is the mass number. For example, protium is represented by 1H1. Deuterium is represented by 1H2. Helium is represented by 2He4. Since atoms and molecules are very tiny entities, we cannot measure them in kilograms or grams. So they are expressed in AMU, which is atomic mass unit, or simply U and Dalton. It has been found that mass of one carbon-12 atom is equal to 1.99 into 10 to the power minus 23 gram. But this number is extremely small. We now know that carbon-12 contains 6 protons and 6 neutrons and 6 electrons. Since the mass of electron is negligible as compared to mass of protons and neutrons, we can say mass of carbon atom arises from the total mass of protons and neutrons. To simplify it further, chemist assign mass of one carbon-12 atom to be 12U. Now, 1.99 into 10 to the power minus 23 gram becomes 12U. In that scale, 1 atomic mass unit, or 1 U, will be equal to 1 by 12 into 1.99 into 10 to the power minus 23 gram, which is 1.66 into 10 to the power minus 24 grams. This is the atomic mass unit, or Dalton. And mass of all atoms are expressed in AMU, or U, or Dalton. All have the same meaning and value. So far, we learned mass of one carbon-12 atom is equal to 12U, and it is due to the mass of protons and neutrons. In the next video, we will discuss different aspects of atomic and molecular mass.